Hello students, welcome to Vista's Learning. This is Shruti, your chemistry tutor. We are in Vista's Learning, where Vista's Learning provides you a quality education for all as we work for right to quality education for all. Students, we are in chemistry. We are in 11th standard chemistry class. Before going with the next topic, as we have seen in the previous sessions, we have done with our chapters, right? Now we are going with a new chapter. Before going to that, I just want to say you a small story. There was a boy who was very intelligent, very much interested in studies. He was even doing good activities, cultural activities like singing, dancing, and also other quiz competitions also. But he has one demerit in himself. What is that? He was very much lazy. His father always insisted that not to be lazy. You have got all the talents and you should not deny or you should not give the preference for laziness. You should give the preference for time. Time is very much important. But he was just listening and he didn't do anything what his father has been said. He was just nodding his head and he was not knowing about what is the loss if I deny or if I am having laziness. One day what happened, he went for the quiz competition. He won the first prize there. But the prize was not announced on that day when the quiz has been held. But the previous day they called him and said, you got a first prize in quiz competition. Congratulations, you have a prize. You can collect it on that day itself. He, as usual, he was very lazy. He didn't collected it. He went the next day to the school or the way the quiz was held and he asked for the prize. But now the prize was not valid. It has no value now. You guess what is the prize is about? He got a ticket for a competition or for a exhibition where he can go on that day when he receives his prize. He denied to receive the prize and he couldn't go for the exhibition. Then what is the use of winning in the quiz, or what is the use what he got the first prize when he cannot utilize it? Then he understood, yes, I need to give the value for the time. Once the time is being done or if it is being gone, I cannot get back that day or that time. Students, we need to value the time. As we know, the time is approaching for the exams. We need to study daily. We need to value each and every second and we need to study, learn. If you don't understand anything, you can ask your teachers, you can come back to us, you can ask your guides, or you can also ask your friends where you can get or gain the knowledge. If you have any of the doubt, don't be lazy to clarify it. On that spot itself, you clarify and you are the one who will gain the knowledge. As I said, according to that boy, he got to know he should value the time. I hope you understand this. The moral of the story is time is very much valuable. We need to value the time. Once it is been gone, we cannot get back it. Got it? And also, not only about the studies, I also insist you to enjoy the time, whatever you have. Be happy, keep smiling, and happy learning too. Getting with our class now. What is this, students? In chemistry, we'll be having all these things. Whenever we say about chemistry, we know reactions, right? So whatever the reactions it is taking place, students, all reactions will undergo these two important terminologies. What is this? You can see here, we have A as A is a substance here which is having 2 extra electrons in it and it loses the electrons. On loss of electron, it is undergoing oxidation. We can say A loses electron and it undergoes oxidation. So this is called as reducing agent, whereas after losing the electron, it is called as oxidized. Here we have oxidizing agent where B has no electrons and it gains the electron and gets reduced. Here we have two terms, oxidation and reduction. With that, oxidized, reduced, and also we have the agents. You can see the agents are opposite to that of what they have been undergone. If it is oxidized, it is called as oxidizing agent. Where it is reduced, we call it as reducing agent. Are you guessing what's the name of the chapter is? The name of the chapter will be the redox reaction. You can see the oxidation plus reduction. We take Re from the reduction part and Red from the reduction part and OX from the oxidation part, and hence we got redox reaction. This is our first lecturing class of redox reaction. Welcome to Vista's Learning. We are getting into the redox reaction, which is the 8th chapter in 11th standard. So these are the things which we are learning in this. This is just a brief thing about the redox reaction, students. Transformation of matter. We know universe is made up of matter, and that transformation from one matter to another, from one kind into another, occurs through the various types of reactions. Obviously, we know that if you have carbon dioxide reacts with oxygen to give carbon dioxide, right? So we have carbon, oxygen and carbon dioxide, three different substances which react together to give the new substance, and they can be broken into, getting back with the carbon dioxide can split into carbon and oxygen again. So you can get transformation of matter from one form to another, which we call the reactions. And we have varieties of reactions. A number of phenomena, both physical as well as biological, are concerned with this redox reaction. If I say in our body, the body is a mechanism where millions of reaction is taking place. Got it? We can say this is a moving lab. In our stomach, we have many juices which is been secreted to digest the food what we eat. Respiration which is taking place is nothing but breaking down of glucose particles or sugar molecules into carbon dioxide, water and energy. So likewise, we have millions of reactions which is taking place, and those reactions, almost all of them, comes under redox reaction. These reactions find extensive use in pharmaceutical, biological, industrial, metallurgical and agricultural areas. These are very much important where you can see metallurgy. Metallurgy is a study of metals. Okay, you can take out the metals from the ores, segregating them from other metals or impurities, and getting the pure metal is coming under metallurgy. So when you see the ores are made up of oxides, sulfides or chlorides of metals. So if I take iron oxide or magnesium oxide, I need to separate oxygen and magnesium such that I'll get only metal of magnesium. So there oxygen is mixed. I need to remove oxygen. So here removal of oxygen will be also called as reduction. So that reduction and oxidation will help in metallurgy. If you are going with the industrial, many of the synthesis takes place. If you want to add the hydrogen or remove the hydrogen, add the oxygen, remove the oxygen, add the electropositive element, remove the electropositive element, all this takes place in synthesis. So in industries or pharmaceuticals or biological, any of these fields, we require this redox reactions. The importance of these reactions is apparent from that the fact of burning different types of fuels for obtaining energy for domestic, transport and other commercial purposes too. If you see here, burning is again we take the metal or a fuel which in terms of oxides, they convert into oxides. So that is again the redox reaction, which we can get it as the types of fuel burn. Even in electrochemical processes, we require this redox reaction. If you take a cell, inside the cell you will be having the glass rod, like you will be having the graphite rods or the thin metals which is been displaced. So the atom is losing the electron or gaining the electron such that electron is in the motion, and hence chemical energy will be converted into electrical energy, where we get that in terms of redox reactions. For extraction of highly reactive metals also, even non-metals, manufacturing of chemical compounds like caustic soda, operations of dry and wet batteries, and corrosion of metals fall within the purview of redox process. So all the things, almost all whatever we see in our routine life will be having this redox reaction or the process of redox reaction. So we need to know about this redox reaction. What is redox reaction? What exactly it has the influence in our life. So coming back with the classical idea of redox reaction. What is exactly the classical idea? How do we call this as oxidation and reduction? The term oxidation was early got from addition of oxygen to an element or a compound. Before, oxidation means earlier stage, they called oxidation means if you add oxygen to any of the element or the compound, we used to call it as oxidation. The following reactions represent oxidation process according to the limited definition of oxidation. That means magnesium you have which is added with the oxygen, which gives magnesium oxide. Here two molecules of magnesium. You can also say two atoms of magnesium, because magnesium is a monoatomic molecule. You can also call two molecules or two atoms of magnesium react with one molecule of oxygen to give 2 moles or 2 molecules of magnesium oxide. You have the second one, sulfur reacting with oxygen to give sulfur oxide. Either it is a metal or a non-metal, they can form the oxide. So they are addition of oxygen, and we call this as oxidation. Oxidation of magnesium, oxidation of sulfur. Next, we have methane, which is reacting with oxygen. We know methane is a fuel which reacts with oxygen to give a high amount of energy. So when methane is reacting with oxygen, it gives you carbon dioxide, water plus huge amount of energy. It might be in light or heat energy. So here what happens is that addition of oxygen is taking place, not for exactly methane, but carbon is acted with addition of oxygen to the carbon separately and addition of oxygen to the hydrogen separately. So carbon is also undergoing oxidation, hydrogen is also undergoing oxidation. In this reaction, hydrogen has been replaced by oxygen, prompted chemists to reinterpret oxygen in terms of removal of hydrogen. You can see here, since the hydrogen is been removed from the carbon, oxygen is been added. Now we can say that hydrogen is been removed from the carbon, right? So from here we also got to know the new definition for oxidation, that is the removal of hydrogen. Removal of hydrogen will be called as oxidation. So the term oxidation was extended as the removal of hydrogen from any of the substances. Before we thought addition of oxygen is called oxidation. After this methane reaction, we understood that removal of hydrogen can also be called as oxidation. So you can see hydrogen sulfide is reacting with oxygen to form sulfur plus water molecule. Here hydrogen is removed from the sulfur. So we can say sulfur is undergoing oxidation. Here sulfur is not added with the oxygen. Understanding? Sulfur is not added with the oxygen, but it is removal of hydrogen, and also we can call the sulfur is undergoing oxidation. Next, the oxidation of magnesium with fluorine, chlorine and sulfur etc. occurs according to the following reactions. We'll see. So, magnesium reacting with fluorine. Here we don't have hydrogen, not oxygen. We have fluorine. So, when magnesium reacts with fluorine, we get magnesium fluoride. Now, we have a doubt whether it is oxidation or not. Yes, later on you can see magnesium reacting with chlorine, which we get the reaction. Magnesium with reaction with sulfur, we get the reaction. So by this, not only the removal of hydrogen is called as oxidation, but we can also say removal of electropositive element is known as oxidation. Got it? And here we can say reduction. We'll just speak about this a bit later. If the removal of electropositive element is been taking place, we can call it as oxidation. Do you think these are undergoing oxidation or not? We'll have a equation here. Potassium ferrocyanide reacting with hydrogen peroxide gives you potassium ferrocyanate plus potassium hydroxide. So the removal of electropositive element potassium, you can see here we have 4 potassium, here we have 3 potassium. That means 1 potassium is being removed. That means loss of 1 electropositive element is taking place. That is, potassium is removed and we get the potassium hydroxide. So we can call this as potassium ferrocyanide is being converted into potassium ferricyanide. So this have loss of 1 positive element and we can call this is undergoing oxidation. The addition of oxygen or electronegative element or removal of hydrogen. This is very much important. I repeat, addition of oxygen, or you can see here addition of electronegative element. Addition of electronegative element is also called as oxidation. Okay. Addition of electronegative element to the Mg, that is magnesium here, which shows that it is undergoing oxidation. So here the addition of oxygen or electronegative element to a substance or removal of hydrogen or removal of electropositive element to a or from a substance is called as oxidation. Did you understand? If I have hydrogen, I am adding oxygen to it. So I get H2O. So here oxygen is added to hydrogen. So I can say it is undergoing oxidation. If I say hydrogen plus fluorine, so I get HF. So it is addition of fluorine to the hydrogen. We can say electronegative element is added to the hydrogen. So it is oxidation. And removal of hydrogen. If I say H2S reacting with oxygen. So what happens? Yes, H2O plus S. So from S, H is been removed. So S is undergoing oxidation. Likewise, we can take removal of electropositive element. For example, if I have KOH plus if I have around some other element which can remove this, I'll take H2O2. So what happens? It will be removed K plus H2O. So 2H2O will get. So from potassium is been removed from OH. So here electropositive element is removed. So it is undergoing oxidation. Water molecule, this is undergoing oxidation and we get water molecule. OH is undergoing oxidation by removal of potassium electropositive element. Got it? So these are the examples for oxidation. So you need to remember addition of oxygen, addition of electronegative element, or removal of hydrogen, removal of electropositive element gives you oxidation. Next, speaking about the reduction, this is exactly vice versa of this oxidation. Removal of oxygen, removal of electronegative element gives you reduction, and addition of hydrogen, addition of electropositive element gives you reduction. Got it? So whatever examples we see, if we are seeing this hydrogen is reacting with oxygen to give water molecule, you can easily understand oxygen is added to hydrogen. So it is undergoing, hydrogen is undergoing oxidation. But we can also say hydrogen is added to oxygen, right? So addition of hydrogen, so it is undergoing reduction. So whatever the reaction we take, reduction and oxidation takes place simultaneously, hence we get the reaction as redox reaction. So here is an example. You can see 2HgO. Hg is mercury. Mercuric oxide gives you mercury plus oxygen. Removal of oxygen, which gives you the oxidation. Next, FeCl2 plus hydrogen gives you FeCl3. Here it is 3, here it is 2. FeCl3 reacting with H2 gives you FeCl2 plus 2HCl. So one electronegative element is removed. So removal of electronegative element. Removal of electronegative element is reduction. But for hydrogen, it is being added. So addition of electronegative element to the hydrogen. So we say hydrogen is undergoing oxidation, whereas FeCl3 is undergoing reduction. It is simultaneously. It is like if I have chocolates, I have to distribute the chocolates. There should be someone to take the chocolates, right? If there is no one, if you refuse to take the chocolate, to whom shall I give? If I am giving, there should be someone to take. Same thing happens here. If you are losing, there should be someone to take that electropositive or electronegative elements. So removal of electronegative element, chlorine from ferric chloride. Here we have ethane, which is reacting with hydrogen, which gives you ethane. So here hydrogen is added to this. Getting that? Hydrogen is added. So when hydrogen is added, this is the addition of hydrogen. So where is the addition of hydrogen? It comes under reduction. Hope you are understanding this. Next we have mercuric chloride, which is reacting with stannous chloride, which gives you mercurous chloride with stannic chloride. So here what happens? We have two chlorine with one Hg. Hg is metal, mercury is a metal, so it is electropositive element. So electropositive element is added here. Whereas for chlorine, stannous chloride, we have two chlorine atoms extra added. So from here to here, electronegative element is added. Addition of electronegative element is called as oxidation. So stannic chloride is undergoing, stannous chloride is converted into stannic chloride, where it is undergoing oxidation, while addition of electropositive element is taken by the mercuric chloride. So it is addition of electropositive element, which gives you reduction. So we just get with an examples here. In the reactions given below, identify the species undergoing oxidation and reduction. Can you do this? Yes, the first one is H2S reacts with chlorine, which gives you HCl plus sulfur. So here what happens? H2S is oxidized. Why? Because H2S is more electronegative element, chlorine is added to H2S. So an addition of hydrogen to the chlorine. So you can say a more electropositive element, hydrogen has been removed from the sulfur. From the sulfur, we are removing this. So it is undergoing reduction. Removal of hydrogen is reduction or oxidation? It is oxidation. So removal of hydrogen is oxidation, sulfur is undergoing oxidation, whereas the hydrogen is reacted with more electronegative chlorine. So compared to that of sulfur, chlorine is more electronegative element. So when removal of this and addition of more electronegative element to the hydrogen, it is undergoing oxidation. So we can say H2S is undergoing oxidation and reduction. That means this is splitting. Hydrogen is added with chlorine. So hydrogen is undergoing oxidation, whereas sulfur is undergoing reduction because it is removal of hydrogen. So chlorine is reduced due to the addition of hydrogen to it. You can say chlorine is reduced because addition of hydrogen is added to the chlorine. So all the three species you can explain. Next question is that Fe3O4 plus 8 aluminium gives you 9 Fe plus 4 Al2O3, that is aluminium oxide, iron plus aluminium oxide. Ferrous oxide, ferric oxide is been giving you the aluminium which is been reacting with aluminium, which gives you iron plus aluminium oxide. So here aluminium is displacing iron from its oxide. So aluminium is oxidized. We can easily find aluminium is in metallic state. It is been oxidized. Addition of oxygen is taking place because oxygen is added to it. And if you see Fe, it is undergoing reduction as oxygen is been removed from the iron. So we can say aluminium is undergoing oxidation, iron or ferric oxide is undergoing reduction. Next question is sodium reacting with hydrogen. So here compared to that of sodium, which is compared to that of sodium and hydrogen, which is electropositive. Sodium is electropositive than hydrogen. You can say with the careful application of concept of electronegativity only we can infer that sodium is oxidized and hydrogen is reduced. Got it? Because hydrogen is more electronegative than sodium. So sodium is more electropositive. By this we can say sodium is undergoing addition of electronegative element which is hydrogen. So sodium is undergoing oxidation, whereas hydrogen is added to the electropositive element. So we can call hydrogen is undergoing reduction. Here is some of the terms which you need to know, students. Oxidized, reduced, oxidation, reduction, oxidizing agent, reducing agent. Now if I speak about agents, what do you mean by agents? If I say LIC agents, those are the ones who support us, who help us to keep up our account in the LIC, right? So the one who is supporting us to undergo that process is called as agents. Okay, so if we have A and B, A is supporting B to undergo oxidation, then B is called as oxidizing agent. I will say A plus B. Okay, B is oxidizing. If B is oxidizing, A should help B to oxidize. Getting? Then we say A is oxidizing agent, and vice versa. If A is reducing, then B should help A to reduce. So we can say B is reducing agent. So agents are not undergoing the same process, they are undergoing opposite process. We have here oxidizing agents, the substances which lose oxygen or gain hydrogen is called oxidizing agent. Can you tell me who loses oxygen is called as what? The one who loses oxygen will be called as reduced, or the one who gains hydrogen will be called as reduction. They are undergoing reduction. The one who undergoes reduction will be called themselves as oxidizing agent. Okay, so reducing agent, the substance which loses hydrogen and gains oxygen is called as reducing agent. Hope you understand here. Zinc oxide plus carbon gives you zinc plus carbon monoxide. So zinc is losing oxygen. So we can say zinc oxide is undergoing reduction. It is losing oxygen. So it is undergoing reduction and it is being reduced. And so we can call zinc oxide as oxidizing agent. Whereas carbon is gaining oxygen from zinc and undergoing zinc carbon oxide. So it is gaining oxygen. So it is undergoing oxidation. We call it as oxidized. When it is been oxidized, it gets a name as reducing agent. It is exactly opposite. Zinc oxide is reduced and it is getting a name as oxidizing agent, whereas carbon is oxidized and it gets a name as reducing agent. You can get to know where there is oxidation, there is always the reduction taking place. So we have some of the questions, students, here. Justify the following reactions are redox reaction. We need to say, as we learned just now, the every reaction, if there is a reduction or if there is a oxidation, there should be a reduction. If there is a reduction, there should be a oxidation. So on this basis, we need to justify this question. So copper oxide reacting with hydrogen gives you copper plus water molecule. Tell me either it is a reduction or oxidation, or is this equation can be called as redox reaction or not. So you can see from copper to copper oxide to copper, the removal of oxygen has taken place. So it is undergoing reduction. From hydrogen to the water, it is addition of oxygen and we call it as oxidation taking place. So here oxygen is removed from copper oxide, therefore it is been reduced to copper, while oxygen is added to hydrogen to form water molecule, so it is oxidized. Copper oxide is reduced to copper, whereas hydrogen is oxidized to water. Thus, this is a redox reaction.